All right, guys. So I just wanted to make a quick overview of some of the general questions. So I'll go through a couple of them and give you kind of pointers, or I'll redirect you to where you can find them in the notes. And then on the multiple select ones, I'll tell you how many answers you have, just to be a little bit clearer there, so you can be a little bit more certain if you're doing this correctly or not. So, all right. So I'm just gonna go through it and make this available for you guys. So number one, you're given two ordered pairs. Essentially, you're told that 3 goes to 5 in this function, 7 goes to 37, and it's asking you for average rate of change on that interval. So we've done some warm-up questions and bell work questions like this one. Remember that your average rate of change is equal to f of x2 minus f of x1 all over x2 minus x1. So for us in this case, that's going to be equal to f of 7 minus f of 3 over 7 take away 3. So simplify that and you'll get your, you should get your correct answer. So, and you can double check with the answer key as well. Number two, which product of factors is equal to this? This is one of our best guessed questions. So I'll let you guys kind of squirm on that one a little bit. You can look up factoring trinomials if you wanted to look that up. Okay, so if you're looking for keywords there, if you wanted to do some research on your own, factoring trinomials. We'll get to this one when we come back from break also. Number three, while I'm at it, number 9 was a best guess also. Number 3, this is a graphing question. You're just looking for the interval that it's increasing. So that means where is it going up as decreasing? Where is it going down as we read left to right? You can also double check your bell work from yesterday for a hint on that one as well. Number 4, let p of x, that's just a function, be a degree 3 polynomial with a negative leading coefficient. So that means the highest exponent is a 3 and the leading coefficient is negative. Which of the following exhibit the same end behavior? Well, remember, check back with your notes for end behavior. Negative odd, because 3 is odd, negative odd functions. That means the left it goes up and on the right it goes down. So you need which of these exhibits the same negative odd behavior. So just glancing, there are 2 answers here. Okay. Number 5, the function v of t describes the velocity of an object when time is greater than 0, because again, we don't look at negative time, so we're not looking to the left of the graph, just from 0 on. And it says, where is the velocity negative? Well, you're just looking in the graph. That's a Desmos question. You're going to graph that and just see where is it negative. Number 4, and this is another end behavior question. If you look right here at your leading term, you're looking for a negative even behavior. Okay. Remember, negative even, that's where it's going down in the same direction on both sides. Number 7, select which of these polynomials is considered an odd function. We talked about this yesterday. At a glance, I see 3 answers here. There are 3 answers for number 7. Number 8, what are the zeros? Again, just graph. This is a graphing question. Throw that in Desmos, and you're looking for the x-intercepts. Number 9, your best guess. We're talking about transformations. I'll let you guys look that up. Or you can play around, try graphing some functions with it. So like if you wanted to explore this in Desmos, it's just kind of like a getting started type situation. You could graph something simple, like say maybe like y equals x squared, and then try another graph. And instead of saying x squared, say parentheses x minus 1 squared, and see what happens to the graph. And you can play around with a couple different graphs. It doesn't have to be squared. It could be cubed. It could be square root, all sorts of stuff. But play around with that, see what kind of transformation you get. Number 10, the function 3x squared plus 12x plus 9 represents a parabola. Find the x-intercepts, the y-intercepts, the minimum or maximum point. Okay, well, this is really just a graphing question. You guys know how to interpret those, hopefully. So graph that with Desmos, and then you can use process of elimination to hone in on your answers. If we're using a little bit of mental math, we know that this is positive even, so it looks like a parabola like this. So we already know it's going to have a minimum. So just with that bit of information, you can go ahead and rule out anything that says max. So like B says max, right there, that's no good. C says maximum, that's no good. So immediately that eliminates two options for you. So start with that, use your process of elimination, graph that, take a look at it. Number 11, how many x-intercepts? Again, that's just a simple graphing question. You're just going to graph it and look. Number 12, solve the quadratic equation. This one looks really, really terrible. It's not as bad as you might think. Okay, you can actually graph this one also by making it a quadratic. Okay, all you need to do is you move this negative 24 to the other side by adding 24. And so your equation becomes 2x squared plus 14x plus 24 equals 0. Well, if you graph this portion in Desmos, you are looking for the roots, and that will solve the same question. Okay, so graph that in Desmos, look for your roots, and that's all you need. Okay, 13 and 14, you have another in behavior question, but again, it's broken it up into a nice little chart here for you, trying to stay organized. So if you notice right here, the first two columns are both x goes to infinity. So these are what happens as you go to the right. Okay, so this one is right and up, that one negative infinity, this is right and down. Same thing over here, these are both left. So it's saying left and up, left and down. So you're just going to describe what behavior matches 13 and 14. So for both of these, you're going to have a pair of answers because you need to know what it does on the left and on the right. So if I'm going to do 13 real quick, 13, my leading term is a negative even. So that means it's going to be opening downward on both sides. So I need to say left and down, right and down. Okay, and so my answers for 13, right and down is option B, left and down is option D. So for 13, my answer would be B, D. So 14 works similarly. 15, which of the following has a vertex in the second quadrant and is concave down? Well, again, we can do a little bit of mental math here just to see about concave down. We know that it needs to have a negative leading coefficient here because these are all quadratics. So we automatically know it's not A and it can't be C. So that already eliminates two options. So you can check and see if it's B or D or E, none of the above. And remember, the vertex is like the minimum or max in this case. So I'd graph it on Desmos, take a look, and see which one of those has a vertex in the second quadrant. And remember, quadrants, they go counterclockwise. This is the first quadrant, second quadrant. Down here on the bottom left is third, bottom right is fourth. So you want a vertex in this quadrant. Number 16, you have this polynomial. It can be written in factored form for you. At which values of x does the graph of the quadratic cross the x-axis? Well, you can do this a number of ways. You can graph it, or this is like several of the problems that we've done for quite a while now, a little bit of mental math here. We know that it should have roots at 7 over 2 and at positive 4. We set these equal to 0 and solve. Okay, so remember, it's like if you're not following 2x minus 7 equals 0, move the 7 over, divide by that 2. You get 7 halves. Now there is decimals, and 2 goes in 7, 3.5. So we're looking for 3.5, comma 4. That's option E. And then number 17, it might be a little bit tough to see. It's kind of small sometimes, but we're just looking for roots. So we're going to do wherever it crosses the x-axis, 1, 2, 3 roots. So make sure you have all 3 answers listed for number 17. Okay. 18 was a little confusing for several people. It is unfortunately typed out. It looks like this is number 27. It's telling you that the average rate of change on this interval is 27. Unfortunately, place period, and it's asking you what value is missing from the table. So remember, when we're setting up our average rate of change, we're going to say, in this case, G. So I need to know what is G of 4, take away G of 1, over 4 take away 1, and we know that that will be equal to 27. And so setting that up, G of 4 is what I don't know. So that's like saying question mark, minus G of 1 is 3, over 4 take away 1 is also 3, equals 27. Well, boom, there we go. We're going to solve that equation for question mark. So we're going to multiply by 3, add 3, and you'll get your answer. 19 was our best guess. You're welcome to look up quadratic formula. That would be the keyword that you need to solve that one, quadratic formula, if you want to try that one on your own. Make sure that if you're doing your corrections, trying to get some extra credit on the best guess ones, make sure you actually include the formula and explain the components. 20. This is a kind of a backwards question. These are always tricky. It says which one of these is not true? And it says, here's your quadratic. Which of the following is not true? Graph is concave up. Well, this is positive, so it's definitely concave up. Y-intercept is 0, -5. Well, if you plug in a 0 quick, that one goes away, that one goes away, you're left with -5. That's true. There's a minimum at -1, -13, or there's a minimum at -2, -9. Well, you plug all those in. You can either test these values or just graph it on Desmos to confirm that. But this one is definitely the minimum. There's also another way of finding the minimum that we'll go into. You can plug in -b over 2a, if you guys know what that means. -b over 2a is going to be the x-coordinate of the minimum. That means for us, -b, that would be -16 over 2a. That's 2 times 8, which is -16 over 16. That tells us the x-coordinate of the minimum is going to be -1. So that's how I know that C is correct. We'll do more with that later. Again, you can totally graph this in Desmos and just check. So if C is true, D is false. And so because I know that there's only, well, no, it says select all. We have to check again. So we know that D is an answer. Let's check E. There's one positive, one negative root. Again, if you graph that on Desmos, you can confirm that that is true. So our only answer for number 20, we only have one answer, and that is D. Okay. 21, which of these is true? Another one, multiple select, be careful with. This is also your best guess question. Okay, because I didn't go through all of those. You're welcome to explore these concepts on your own. Let's see here, 22. Okay, the function f of x, and it gives you another parabola. It represents, let's see, it is a parabola, excuse me. Find the x-intercept, y-intercept, minimum or maximum, whichever exists to the nearest tenth. Again, this is positive leading term. It's got a 1 right there. So we know it opens like this. So we know it has a minimum. So again, just like the last one, anything that says max is automatically ruled out. So you have a maximum right here and a maximum right there. So we know B and C are no good. For the others, y-intercept, quick check. You plug in a 0, that one goes away, that one goes away. You're left with 24. So that rules out option D. So you automatically have a 50-50 chance, A or E. To confirm that one, I would just plug that into Desmos and graph it. 23, g of x is a polynomial of degree 5. That means the leading exponent is 5. It has a negative leading coefficient. Which of the following best describe the end behavior? Go back, check your notes. This is just another end behavior question, nothing serious. 24, which of these polynomials functions is considered an even function? We talked about that one in Bellwork also. Quick glance, I see 2 answers here. There are 2 even function. And 25, which of the following has a positive y-intercept. So again, to find the y-intercept, you plug in 0. So on A, plugging in a 0, boom, boom, left with -5. That one's no good. I want a positive y-intercept. This one will be negative. So A is out. B, plugging in a 0 there, that's going to be 2 times 0 minus 4 is -4. 0 plus 1 is 1. Positive times a positive is a negative answer. That's no good because I want a positive y-intercept. C, plugging in zeros, that goes away, that goes away, that goes away. We have 6 left. That's true. So C is a positive y-intercept. D, again, just plug a 0 in for x. 0 plus 3 is 3. Squared is 9. That's -9 plus 8 is -1. That one's no good. E, this is 3 times 0 plus 1 is 1. 0 plus 4 is 4. That's going to be positive 12. That one's also positive. So 2 answers for 25. On this slide, 29 was a best guess question, so you're welcome to work on that one. Same sort of situation. You have a translated right 2 units and up 3, so you can play around with that and see what happens. 26, as the value of x increases, the value of h of x decreases. Okay. Well, that's another way of talking about in behavior. So that we're saying as x increases, that goes to the right. So it's saying as we go to the right, h decreases. That means it goes down. So it's doing this on the right. And as x decreases, that means left, the value of h increases. So that's left and up. And so you're asking which of these functions exhibits the same in behavior? Quick glance here. There is actually only one answer here for 26. There's one answer. You're looking for a negative odd leading coefficient. 27. You're getting one more equation. One more equation here. Determine profit Y in thousands of dollars for the sale of the product X. So just interpreting that, that means if I wanted to know what kind of profit I get when I only charge $4, for instance, if I plug in 4, that tells me how much profit I make when the product only cost $4. So that's how we're doing that. And it's asking you which of these is true. A says there is a 0.611. This means that if the company sells the product for $6, their profit is $11,000. Well, that's done. I guess we should be thorough, but it looks like there's only one answer. It doesn't say multiple select. B, the graph is concave up. No, it's got a negative number out front. Concave down is quadratic. C, the y-intercept is 0, 13. Let's double check. 0 minus 5 is negative 5 squared is 25. That's negative 50. Definitely not 13. That's not true. D, the zeros are negative 1 and 5. Okay, let's plug that in. Negative 1, that's negative 6 squared is 36. No, that's not a 0. Remember, if it's 0, when you plug it in, it should get a 0 out. So that's already wrong. And then E says the vertex is 513. That is true. This means that selling the product at $5 creates the minimum profit of $13,000. Well, remember, this is concave down. And so it's not going to be a minimum. It's actually a maximum. So if they had said maximum right here, then E would be true. But unfortunately, that is also false. 28. A rock is dropped from a hot air balloon at a height of 200 meters. We're having this formula here where T is time in seconds. And this is just a good old question. This is another average rate of change. The interval is from 2 to 5. Remember your steps. You got to set up your formula. Find your outputs. In this case, the output would be h of 2 and h of 5. You'll do a little bit of scratch work finding that. And then lastly, step 3, we simplify. Right? We had several questions in our notes just like 28. So feel free to go back and check those for help. And that'll do it. So again, guys, good luck. If you have any specific questions that this was not able to help you with, please ask. This is the last big focus before the end of quarter 1. And make sure you're paying attention to all the guidelines for grades and corrections and that sort of thing. Thanks.